Chapter 3, Episode 4 is about calculating density. Again, it's equal to mass over volume. What is the density of a sample of sugar with a mass of 250.0 grams and a volume of 157.3 cubic centimeters? Now again, you always start with a formula. Again, it's equal to mass over volume. By the way, the formula, or the symbol rather, the symbol for density is the Greek letter rho, which is something like this. So it's something like letter P. Okay, again, this is the symbol for density. Again, on this case, given yung mass, then given yung volume, so just put this one in the formula. Again, the mass is equal to 250.0 grams over the volume. We have 157.3 cubic centimeters. Then if you divide this one, we have 1.589 cubic grams per cubic centimeter. So just copy the units given here, grams over grams per cubic centimeters. Note that we have 4 sig figs here because we also have 4 significant figures, and this is division. So you count the number of significant figures in the measurements. We have 4 sig figs, 4 sig figs. So the answer must also be rounded to 4 significant figures. Now, next problem, we have an object has a mass of 40 grams and displaces 15 ml of water. What is the density of the water? Again, you start with the formula. Density is equal to mass over volume. The mass here is given. We have 40 grams. Then here it says here, this one displaces 15 ml of water. So when you added the object on the water, nag-increase yung water by 15 ml. So again, this is coming from the volume of the object. So this is the volume of the object. So we have 15 ml. Then divide this one, 40 divided by 15. By the way, here on this number, we have one significant figure because, again, this is a trailing zero, and trailing zeros are only significant if there is a decimal point in the number. On this case, walang decimal number. It means this number has only one significant figure. Then here we have two significant figure. So in this case, you round the answer to one significant figure, the lowest number of significant figures from the given. So in this case, you round this one to 3 grams per ml. That's the answer for the second item. Next, what is the density of a rectangular object with a mass of 90.0 grams and the length of 2.0 centimeters, width of 2.5 centimeters, and height 15 centimeters? Again, it's equal to mass over volume, and given yung mass, we have 90.0 grams. Then for the volume, I don't see the volume here directly, but this one is a rectangular object, and I know that for this one is equal to length times width times height times height. So in this case, just put these numbers in the formula for the volume. Again, we have 2 centimeters times 2.5 centimeters times 15.0 centimeters, and this is equal to 75 cubic centimeters. 75 cubic centimeters. So this one is from ito, so that's cm times cm times cm. So of course you add the exponents. So 1, 2, 3. So this is 75 cubic centimeters. That's the volume of the object. We have 75 cubic centimeters. Then if you divide this one, it's equal to 1.2 gram per cubic centimeters. On this case, we have two significant figures because, again, we have two significant figures here in the given. Next, gold has a density of 19.3 grams per cubic centimeter. What is the volume of 500 grams of gold metal? So in this case, it's different because given yung density, but we don't have the volume of the metal. We can again start with the formula. It's equal to mass over volume. On this case, given yung density, which is equal to 19.3 grams, 19.3 grams per cubic centimeters. Then here, the mass is equal to 500 grams, 500 grams. Then the volume is unknown, so I'll just put here V for the meantime. Again, I'm looking for V. What should I do? I can do cross multiplication. Of course, this one is a whole number. It has a denominator of 1. Then again, cross multiplication. So we have V times, again, cross multiplication, this one and this one. V times 19.3 grams per cubic centimeters. And then 1 times this one is equal to 500.0 grams. Then I'm looking for the V here. So what should I do? Divide both sides by this number, 19.3 grams per cubic centimeters. 19.3 grams per cubic centimeters. Then cancel this one. What's left here is V is equal to 25.9. So 25.9 grams per cubic centimeters. Again, we have three significant figures in the answer because here we only have three significant figures in one of the measurement. So that's the answer for this one. So by the way, we have here a shortcut for this. So you can look on this triangle. So for example, if you are, again, measuring for the volume, just cover this one. So it's equal to mass over the density. Now, if you're looking for the mass, just cover this one. So we have that is equal to density times the volume. Then again, for the density, it's equal to mass over volume.